Welcome back. The PLC Professor presents How to Program a PLC, Volume 1.5. This is the 6th segment on this one particular application. We picked a very simple application for our very first How to Program a PLC. And this particular one, we went through the electrical design, and then we wrote the logic. Actually, we did some review on the graphical user interface for Micro Starter Lite. But anyway, the 4th segment added a little more advanced logic that used a single push button instead of 3 push buttons. In this one, we're going to do a simulation. This would be similar to what they call a FAT, Factory Acceptance Test, where you actually have to run the control system without a real process. So what we've done is we're going to create some logic that simulates a door going up and down based on time. And here's the logic. So we'll go through and talk a little bit about this logic, and then we'll review some things and then move on. The first rung is a do nothing rung. Notice that the action is no op, do not use, no operation, do not use. And we did this because we want access to B3310, the push button, with this logic. In other words, we want to be able to toggle B3310, and the other logic that we added in the last segment, it'll be in the background operating, but we can see our new logic, the simulator, actually execute. So ignoring the first rung, because it just gives us access to operate the door and see this logic execute. The first thing that we have is a free-running timer, and it's set for a time base of 1 second, a preset of 1. And the permissive, the condition on this rung is that the timer is not done. Well, if the timer hasn't started, then it's not done. So the first time the program scans through here, T420 is not done. That instruction is true. So it enables the timer, and the timer starts timing. The program will probably scan through 600, 700, 800 times before that timer has reached 1 second. When the timer reaches 1 second, in other words, the cumulate equals the preset. And if you're not familiar with these instructions, you need to go watch the other series, especially from the lab project manual discussions, where we go into detail on the timers and counters. So, for one program scan, that timer will be done, and the timer done bit turns on. The next scan around, the condition on this rung, the free running timer not being done, that'll be false. That will reset the timer, and then the next scan after that, the condition will be true again, and it'll start all over again. So basically, this free running timer puts out a 1 scan done bit or pulse every 1 second. And what we're going to do is we're going to count these pulses, and we're going to treat them as distance moved by the garage door. So if you visualize a garage door, I have a near photographic memory, and I'm kind of playing a movie in my head, and I think that it moves about 6 to 9 inches per second. So just to be safe, we're going to use 18 pulses, which is 6 to 8 or 9 feet of travel. Because remember, the garage door actually travels past the opening to make sure it clears the opening. Okay, so that's our free running timer. It'll set its done bit high for 1 scan every 1 second interval. The next rung, we're looking at the motor up bit, and remember that at this point our application is 100% virtual. virtual. We're not using any real I/O. It's all internal bits. You can do this all right from your simulator. Now you can use input and output bits, I bits and O bits, but they're just bits of memory, just like the B3 bits. And if you're using the simulator, you don't have any field devices anyway. So it might be better if you used bits from file 1 for inputs and file 0 for outputs, just so it looks more like the real thing. However, you can do it this way. So the third rung, the first bit, motor up. That bit is going to be on if we've energized the garage door motor in the up or forward direction. So as long as the motor is true, the motor up is true, every time that timer puts out a pulse and the counter is not done, then it's going to count up. And there's two counter instructions there, CTU, CTD. There is only one counter, and that counter is C5:20. So a count up and a count down instruction is not a count up and a count down counter. They are instructions that execute against a counter data type. In this case, we use C5:20 as our counter data type. So every time the count up instruction, the rung that it's in, every time that rung goes from false to true, it will count up one. It'll increment the accumulate value, and it'll keep doing that until the accumulate equals the preset. It will set the done bit. Now you can see earlier in the rung, the last of the three conditions, once the accumulate equals the preset, 18 in this case, next scan around, that bit will be false, C20 not done, door position. The counter won't count up anymore. And then we also use that done bit in the very last rung down at the bottom, door position, C5:20 done. We use that to set our up limit switch, meaning that we've tripped the up limit switch. Now you got to be careful when you're doing these virtual processes, because the normally open and normally closed business of field devices can bite you in the butt. We like the normally closed limit switch for up and down, because if it fails, the door won't go up or down. So be careful whether you're using true if on or true if off in your main logic. You kind of have to match. So in this case, we're turning on B332 to say that the limit switch is up. Well, if the limit switch is up in the electrical circuit, then the limit switch would have broken continuity, opened, and prevented current from flowing through the motor. Okay, so that's the third rung. Counts up in seconds as long as the motor up is on and it is not done. So if you were to stop, click that push button up at the top rung while you were on the way up, then motor up signal would leave and the counter would sit right in whatever position you left it. So the count in C5:20, the accumulate, you could say that equals increments of 6 inches of travel of the garage door. If we wanted to be real clever, we could have probably did some other time base, did a little math, made it in inches of travel, feet of travel, but you get the basic idea. Okay, so the fourth rung does the same thing that the third rung does, except it does it for the down direction. So if the motor down is on, every time the Freerunning Timer turns on the done bit, once every 1 second, and if the position of the door, the accumulate of the counter, is greater than 0, we don't want to count below 0. If it's greater than 0, then we're going to count down. So we have one counter and two counter instructions. We count up when we're going up, we count down when we're going down. So far, so good. The fifth rung, we use this rung to determine that the door is all the way down. So if we count all the way down to 0, it's not going to count down any further because of the rung right before it. So when the counter cumulative equals 0, then we turn on the limits down switch, or the limit switch for the down position. We turn it on. Now you could use equal in the last rung. When it equals 18, then you're up. However, I wanted to allow you to change the height of your door, or the time it takes to get all the way up or all the way down. So you can go in and change the preset on the counter, and that last rung will always work correctly. Because if you change it to 24, then the door position counter isn't going to say it's up until it gets to 24. So the done bit always represents the accumulate equaling the preset. Okay, so the door is down when the counter is at 0. The door is up when the counter is done. Real simple. So you're looking at a garage door motor simulator. And if you interface this correctly with your other logic, when I say interface it correctly, I mean the push button up there is the push button in your other logic. Motor up and motor down, B310, B311, are the bits that you're turning on and off when you push the up button or the down button. And your limit down switch and limit up switch are B334 and B332. And you're also going to have to make sure you use truth on, truth off appropriately, because if right now it says the limit up switch is on, or it's in the up position. So you would have to reverse that to stop it from traveling any further up when this bit comes on. Just keep all that in mind. So I think what we're going to do now is we're going to go to Micro Starter Lite and actually execute this code live for some entertainment. Okay, I tried to fit the active ladder view as large as possible in my recording window. And what you're looking at is you're looking at the previous code, the single push button using the one-shot instruction to determine whether the push button means stop, go up, go down. Then of course the additional branch to clear that push button so you don't have to retoggle it. If we scroll down, this is our actual main control circuit right here. Stop button, go up, go down, and of course motor up, motor down. And then remember we had our timer to give us illumination. Now there's one thing I didn't mention yet, and that is in the main routine we have to add a jump to subroutine, because that other code, motor simulate right here at the bottom, this code I'm going to put in another routine, routine 6. So ladder 2 is the only file that executes automatically when you go to the run mode. If you want to use any of those other ladder files, you have to have a JSR in ladder 2 to jump to them. Now you can nest JSRs inside of subroutines, but we're not going there. So in ladder 2 we added a rung that unconditionally jumps to subroutine 6, and we name that subroutine motor simulate. And here's the logic. There's your push button. Remember we said we put it there to give you access to it so you can see this operate. So I'm going to go back to main program here, and I'm going to scroll up. Looking at this rung, if we press the go up button, will we turn on motor up? No. Why? Because the limit switch is already made. So this is false. We can't go any higher. So if we push the push button, if we're going to go anywhere, we're going to go down. So if we go up here and look at our logic, remember here's our push button. And if I push that, toggle this bit right now, which would be like pushing the push button, this branch is false. This branch is false because the up limit switch is made, but this one is true. The down limit switch is not actuated, and the up limit switch is, so we can go down. So if I toggle this bit, you didn't see it, but this was on for one program scan, but look, the motor down is on. And if we go to our motor simulate, you can see that the door position is counting down. And if I stop it, I stopped it with 3 counts to go. Remember, go back here, what logic is going to be true when we trigger the button again? Remember, we said that if the door is not all the way up or all the way down, if it's in the middle and you push the button to get it going again, it's always going to go up. So we'll toggle that bit. You didn't see it, but that bit went true for one program scan, a thousandth of a second. Now you see it's going up. See, it's counting up. If I push this button, all it can do is stop. If I push the button again, it starts up again. Once it reaches the count, doors all the way up, see the up limit switch is now made, and if I push this button again, it starts counting down. Now, another reason for allowing you to adjust the preset is because you may not want to sit around and twiddle your thumbs while this is going down. 4, 3, 2, 1, 0. Okay? The down limit switch is now made. So you can see this simulates the movement of the door between the 2 limit switches. And we trigger it with motor up and motor down. We select what we're going to do from the single push button. So if you go back over here and look, right now the only thing the door can do is go up. So if we toggle that bit, see the motor's going up. If we toggle that bit again, it stopped. If we toggle the bit again, it keeps on going up. And it'll keep on going up until it's all the way up. You'll see this go false. You can't see the counter, but it's counting up right now when it gets to the top there. Hit 18. This went false, cleared out the request to go up. Now look, this much of this branch is true. So if we hit the button again, see, we turn on the down, hit it again, it stops. Now remember, it's not up, it's not down, it's in the middle. So what's this going to do? What's this logic going to do? Well, look right here and you can see. The only branch that can go true is to go up. So if we toggle it, the motor goes up again until it hits the limit switch. So this is really not that complicated, but it does give you, I think, a little bit of a feel for more advanced thinking in your programming. As a matter of fact, there are some people that program this way quite often. In other words, they write their code with all internal bits from B3 or N7 file, and then they simulate temperatures rising. Now you could use this count up to count up degrees. So if you want to do a process where there was a rise in temperature, and when the temperature got to a certain point, you turned off a steam valve, and then you would have a decay rate. In other words, you would count down maybe at a much slower rate. So we're just using one simple timer here to generate 1 second pulses 1 second apart. But you can, think up even more ways of doing this one application than we've done here. Well, alrighty then. Thank you for watching how to program a PLC. brought to you from the Complete PLC Learn series by the PLC Professor website and the PLC Professor YouTube channel. This has been a nice weekend doing these videos. I hope you appreciate them. We appreciate you viewing them. I don't think we're going to squeeze any more out of this application. I was tempted to add a little bit more logic that remembers whether it was going up or going down when you stopped it. That way when you hit the button it would continue going in the same direction. Very simple logic to add. Maybe we'll save that for V1.6. In the meantime, we're working on an RSLogix 5000 manual, and we're working on more lectures for RSLogix 5000. All of the work that I do now is in R&D is for RSLogix 5000, the Logix engine, Compact Logix, Control Logix, and it's been quite a while since I've done anything with 500 other than doing these videos. But I hate to let all of that experience from PLC 2, PLC 3, PLC 5, and then there was the SLIC 100, SLIC 150. There was also a PLC 4 in there that was short-lived. And then after that came the SLIC 500. That was the first really new style, new footprint, pre-declared variables, flexible, supported quite a few applications. And then of course back around 2000 or so they kicked off Control Logix, and now that came Soft Logix, Compact Logix, Drive Logix, Flex Logix. And so I've got a lot of materials that I want to put on this channel in the 5000 arena, and I will do some more of these applications for 500 though. Remember I mentioned a factory air compressor sequencing logic and maybe some conveyor logic. Anyway, have a good life. Thank you for watching. Bye-bye.